Good morning. Today we are going to combine functions and we're going to do it 5 ways: adding, subtracting, multiplying, dividing, and composite functions. So in addition to combining our functions, we're also going to state the domain of our combined functions. So let's start with additions. So you see up at the top, f of x is 2x squared minus 1, and g of x is x plus 3. So we're going to start by combining f of x and g of x through addition. So that will be 2x squared minus 1, which is f of x, plus x plus 3. From this point, all you're doing are combining like terms. So 2x squared does not have a like term, so we'll bring that down. X does not have a like term, we'll bring that down. And we'll combine negative 1 and 3 to get positive 2. So now we've combined it, and let's state the domain of our combined function. There are no restrictions on this domain, so we can use all x values in the real number system. So our domain will be from negative to positive infinity. All right, now let's subtract. With subtraction, you have to be a little careful. Because we are subtracting an expression, you want to put that expression in parentheses. So f of x says 2x squared minus 1 minus g of x, which is in parentheses x plus 3. Now, an expression behind a minus sign changes everything in the expression to its opposite. So we need to change this to say 2x squared minus 1 minus x minus 3. So now let's combine our like terms. So we'll have 2x squared minus x minus 4. And this is our f of x minus g of x. And again, no restrictions on the domain. So our domain is from negative to positive infinity. Okay, now let's get ready to multiply. Because we have two binomials, our multiplication is pretty much foiling. Make sure that we have enough room. I'll put our expressions to the side. So we'll have 2x squared minus 1 times x plus 3. All right, so foiling, we'll have first terms, which is 2x squared times x. So that'll give us a 2x cubed. Outer terms are 2x and 3, so that'll be plus 2x squared and 3, so that'll be plus 6x squared. Inner terms are negative 1 and x, so that'll be minus x. Last terms are negative 1 times 3, so that'll be a negative 3. So now let's combine what we can. And remember, order is important, so that'll be 2x cubed plus 6x squared. And it is actually in order because we don't have any like terms. Once again, no restriction on the domain, so the domain is from positive to negative infinity. I'm sorry, from negative to positive infinity. All right, let's look at our last combination here of our 4 operations. And our last one is division. So basically, this is going to be 2x squared minus 1 over x plus 3. But because we have a variable in the denominator, there are going to be values of x that we cannot have because we cannot take a chance on our denominator being 0. So let's determine what values of x we cannot have. So let's set x plus 3 equal to 0 and solve for x. So x cannot equal negative 3. So now our domain is going to be a union from negative infinity to negative 3. And that will be union with from negative 3 to infinity. Okay, so simply put, those are our 4 operations. And I think that you will be just fine with doing the second problem on your own. So now let's go down, let's go to the back where we're actually doing another way of combining functions, and let's do a composite. So notice this small open circle here between our 2 functions. That means a composite, and another way to write that would be f of g of x. So just presently, I'm just going to do the first problem because we'll get more exercises in problems number 5. All right, so here we want f of g of x. So what that means is, let's write it out first. So I like writing it f of g of x. Then I'm going to replace g of x with what the actual function equals. So g of x is x squared minus 4. So that means in my function of f, this is my new x. So I'm just going to look at what f is doing to x. So it has a 1 as my numerator, and down here, all it's doing is adding 1 to x. So here's my new x, and I'm going to add 1 to it. So my final answer is 1 over x squared minus 3. And that's the composite of f of g of x for example 3. Let's go down to example 5, because here I'm doing a lot of experiments. And actually, instead of number 5, let's go to number 6. All right, so in number 6, we need to do f of g of x, g of f of x, and f of g of 6. So let's start off by labeling these A, B, and C. All right, so A says f of g of x. So that's going to be f of g of x is x squared plus x plus 1. So now remember, this is my new x in f. The only thing f is doing is subtracting x from 8. So now this is going to be 8 minus, remember this is an expression in parentheses, so this is going to be 8 minus x squared plus x plus 1. So remember, this is an expression behind a minus sign. So let's rewrite this to say 8 minus x squared minus x minus 1, which basically equals 8. Let's go in order, which will be negative x squared minus x plus 7. So this is my composite of f of g of x. Now let's do B, which is g of f of x. So f of x is 8 minus x. So this is my new x in g. So g is squaring x, then adding x, then adding 1. So that's exactly what I'm going to do. I'm going to square 8 minus x, then I'm going to add it, and then I'm going to add 1. So I'm going to square the quick way. If you remember, a quick way to square this is square the first term, so that'll be 64, minus 2 times 8 times x, so that'll be 16x, And then x squared, x squared is x squared, so that'd be plus x squared. Then we'll have our plus 8 minus x plus 1. I only put that in parentheses so that you knew I was substituting. So now let's combine our like terms. X squared should come first, so that'll be x squared. I have a minus 16x and a minus x, so that's minus 17x. And then I have 64 plus 8 plus 1, so that'll be plus 73. And here is my composite of g of f of x. Now lastly, it says f of g of 6. So there are two ways you can do this. We already know what f of g is. So I can take what I know f of g is and just put a 6 in there. So I can do a negative 6 squared. Remember that negative sign is on the outside. Minus 6 plus 7. Again, the parentheses are just because that's my substitution. So this would be a negative 36 minus 6 plus 7, which gives me a negative 35. Or you can first find g of 6. So g of 6 is going to be 6 squared plus 6 plus 1, and that gives me 43. Now I can find f of 43, which is 8 minus 43, which gives me a negative 35. So the reason you would do it the second way is because you may not know what the composite is. So when you don't know what the composite is, get the value of the inside function, use that value for the outside function. All right, this ends today. I want you to go ahead and do the worksheet that you were given. Thank you and have a great day. Bye-bye.